Okay, so we want to graph these two functions and find when they meet. That's the idea of this question. So we have, first of all, x plus y equals 7. That's a linear equation. Subtract x from both sides, and you get y equals 7 minus x. This means, of course, 7 is your y-intercept. This is in mx plus b format. So b equals 7, and the slope equals -1. So now we can find when this line meets the quadratic quickly algebraically. I know they want it graphically, but I like to support it with the algebra here. So at some point then, 7 minus x is going to equal the quadratic, minus x squared plus 6x minus 3. And here we're going to add x on the right side and subtract 7 from both sides. So then 0, right, this all cancels out, equals -x squared plus 7x minus 10. So here we have minus 10, factors of -10 that add to 7. What could they be? Well, we can't get that straight away because there's no factors of -10 that add up to positive 7. So here, right, where these two things cross, at first you might be a little bit lost, but then maybe we realize that because it's -x squared, we can invert everything. So multiply everything by -1. We get 0 equals x squared minus 7x plus 10. So now the task is a little bit different. We're trying to find factors of positive 10 that add a -7, and that we can do because the factors of 10 could be -2 and -5. Multiply those two, we get positive 10, but if we add them, we get -7. What does this mean? Well, this means the two functions meet at these 2 points. So here we can just find the points by finishing this. Let me clear this off. Clear this off here. So then x minus 2 could equal 0. If we add 2 to both sides, x equals 2. And we know they meet at a point where x equals 2. If we plug in 2 to our linear equation, the 7 minus x, it's just 7 minus 2, and y equals 5. So they meet at the point 2, 5. And then here, x minus 5 equals 0. Add 5 to both sides. Okay, x equals 5. Well, then 7 minus 5 is 2. So when x equals 2, y equals, when x equals 5, y equals 2. Right, the reverses of each other, 5, 2. So this helps us because now we can graph. Let's go back. Our line 7 minus x, we're at 7, 1, 2, 3, 4, 5, 6, 7. That's our y-intercept. Minus x is a slope of -1. The line's just decreasing like this. So here, right, we just line this up. That's our linear equation, that y equals 7 minus x. And we know that it meets the quadratic at these 2 points. So we just need 3 points to kind of estimate the quadratic. So let's graph that. So here we have 2, 5, and that is on the line as well as it should be, and 5, 2, 1, 2, 3, 4, 5, 2 here. These 2 points, 2, 5, and 5, 2, are on the quadratic. All we need to find next is the vertex. And that's easy to do once you realize that -b over 2a is always the axis of symmetry. So b is 6, so -b is -6 over 2 times -1, 2 times a. Right, a is this -1 value. You get -6 over -2, so that means that's 3. So the line x equals 3, right, 1, 2, 3, here, is the axis of symmetry. Although something seems off there. Let me go back a second. The axis of symmetry has to be about halfway between these 2 points here. So here, if I'm at 2, 5 and 5, 2, the halfway point should be what? It should be 2.5, right? Not 3. Something's a little bit off. Oh, I'm sorry. No, it's okay. These are not the roots of the equation. So here, if we draw this line 3, let me explain. Here, this is the line x equals 3. This is the axis of symmetry. It doesn't seem symmetric here, right? But I was thinking the axis of symmetry has to be halfway between your roots, not between every point on the graph, right? Only between points of corresponding height, which we don't even have here. So let me just find the vertex, and then I think you'll understand. So if x equals 3 and it crosses the vertex somewhere, plug 3 in. negative 3 squared plus 18, 6 times 3 minus 3, and we'll find the vertex. Be careful here at negative x squared. We square x and then apply the negative sign. So it's 3 squared or 9 and then negative 9 because of the way it's written. It wouldn't be positive unless the negative x was in parentheses. Plus 18 minus 3. Negative 9 plus 18, what's that? Well, that's 9. Minus 3 equals 6. So the point 3, 6, 1, 2, 3, and then here, 6 is your vertex. It's right here. Alright. All this work allows us to kind of graph the parabola here. And I'm just going to say when x is 0, I'm going to use that as a reference point, we're at negative 3. If you plug in 0 here, you would see that. This point's going to be there as well. So as a guide, use 0 as a guide. It's going to help you. Here you can see that that's not the worst, not the best drawing, but here this quadratic now is graphed. Y equals negative x squared plus 6x minus 3. And we have the 2 points of intersection here and here. You would label those, and we've graphed it. And as a recap, the first thing we did was took our line, graphed it, in mx plus b format, set the two things equal to each other, and that allows us to find the x values when the points meet. When x equals 2 and y equals 5, we plug those into our lines and got the y values. That gave us the points where these things meet. And then we found the axis of symmetry for the quadratic, plugged in that value, x equals 3, to get the vertex, and then graphed. I used as well this point. When x is 0, I plugged that into the quadratic and got the y value of negative 3. When x is 0, you can just automatically kind of get a snapshot that this number is where the y-intercept is. So here we've got this intersection, and you can do it on the graphing calculator. Here I have it set up in the y equals mode, plugged everything in, hit graph, and you'll see that it works. But if you want to find the intersections here, you'd hit second, trace, and then intersect. Then you want to just toggle between the curves, first curve, and they consider a line a curve, right? And then right here. Oops. Sometimes it's a little hard, difficult to toggle between the two. But there's one intersection 2, 5, and then you can kind of toggle over to the right and press enter, and it will get the other intersection as well. Okay. Okay, what's the, they want to find when these two functions meet. They want us to solve it algebraically. So when does 2x plus 1 equal x squared, right, plus 2x minus 8? So get everything to one side. So subtract 2x minus 1, subtract 2x minus 1, and this is 0, equals x squared, negative 8 minus 1 is negative 9, right? This cancels out. X squared minus 9 is the difference of two squares, so it's the factored form is x minus 3 times x plus 3. I'm just taking the square root of both terms. And this equals 0, right? So that means x minus 3 could equal 0. And if that's true, add 3 to both sides and x equals 3. Or x plus 3 could equal 0, and then subtract 3 from both sides, and x equals negative 3. Those are the x values, but we need the y values. If these two things meet somewhere, like maybe here's your quadratic and here's your line, they're going to meet at x values, right? But we need to know the points, the locations. So we plug these points in. Let's plug into our line because the line and the quadratic are equal at these 2 points. We can use either line, either equation. So 2x, so 2 times 3 plus 1. That's 6, that's 7. So one of the points is 3, 7. Then the other one would be 2 times negative 3 plus 1. That's negative 6 plus 1, or negative 5. So the other point is negative 3, 5, and that's your answer. What is the solution set to the equation, system of equations x plus y equals 5 and x squared minus 25 equals y? Well, when these two things are equal to each other, that's your solution set. Now you can just plug these points in to see what's true, and whichever set has both points that work for both equations, that's the answer. But here, let's solve it algebraically. Subtract x from both sides here, so get y equals 5 minus x. Oops, 5 minus x. And since 5 minus x equals y here, and x squared minus 25 equals y there, we're going to set them equal to each other to see when they meet. Okay. So here on the right-hand side, this is the difference of two squares. So we can quickly factor. Square root of x squared is x, square root of 25 is 5, and it's plus minus. And that equals 5 minus x. Alright, so here, right, these two things are equal. What do we do next? Well, what I would do is divide both sides by x minus 5, right? excuse me, go back a second. I was going to divide by x minus 5, but what I'm trying to do is cancel out here, and that's not working yet. So let me go back. I'm going to reverse. I'm going to not factor for a second. I'm going to instead add x and subtract 5. Usually with these kind of problems, it seems that the best step is to just get everything to one side first. These cancel out. This is 0. X squared plus x, can't combine that. They're not like terms. Negative 25 minus 5 is minus 30. So what factors of 30, if you add them, get positive 1? Well, 6 times 5 is 30. So positive 6 times negative 5 works, because if we multiply those two, we get negative 30, and if we add them, we get plus 1. This equals 0. So that means that x plus 6 could equal 0. Subtract 6, x is negative 6. Or x minus 5 could equal 0. Add 5, and x equals 5. So 2 points have to have the x values of 5 and negative 6. And if we plug in those values and get into the line, which is easier to work with than the other one, we get the points. So our line 5 minus x, so if x is negative 6, we have 5 minus negative 6, which is 11. So one of our points is negative 6, 11. The other one, 5 minus 5, which is 0. The other point then is 5, 0. We have 2 points now, negative 6, 11, and 5, 0. Choice 2.